Okay, did you work on these first before you found this answer key video? Excellent. Let's look at number 1. Oh, it's in radians, isn't it? So 7 pi over 8. Well, now I have a little bit of a challenge because the radians are not in denominators of 8. These two have a denominator of 2. These two have basically a denominator of 1. So I need to figure out where 7 pi over 8 is located, which quadrant. How am I going to do it? I'm going to turn everything into a denominator of 8. 0 radians is still just 0. Pi over 2, if I write it with a denominator of 8, yeah, that would be 4 pi over 8, wouldn't it? Okay, pi as a denominator of 8. Right now it's over 1. Good, 8 pi over 8. I think I'm going to stop. Because I've got 0, if I really want to write this, 0 pi over 8, 4 pi over 8, 8 pi over 8. So where's 7 pi over 8? 7 pi over 8 falls between 4 pi over 8 and 8 pi over 8, which means this is a quadrant 2 angle. Okay, and now I am going in this direction into quadrant 2. Is that the positive or negative? Yeah, that's the negative direction, isn't it? So 7 pi over 8. So the question is, 8 pi over 8 minus what is 7 pi over 8? You're like, 1 pi over 8. Well, then there's your reference angle. Good? It's helpful to have the denominators in radian measurement to be the exact same denominator as what they gave you to work with. Good? Okay. Let's look at problem 2. And if you haven't done it yet, do it. I'm going to get my little handy-dandy eraser and get rid of these 7 pi's over 8s and all that great stuff. So, problem number 2. That's 224 degrees, isn't it? Okay, well, it's in degree mode, so we're more familiar with it. First off, which quadrant is that in? Good, that's quadrant 3, so that was pretty easy. And now, yeah, now you've got to figure out what your reference angle is, isn't it? Okay, so this is quadrant 3. And it's here, isn't it? So 224 degrees. And when you go in the same direction as the labeling, this is becoming an addition problem, isn't it? So, by the way, you can literally write it as 180 degrees plus what is equal to 224 degrees, right? That's a nice little equation you could actually set up for yourself. And so your angle, how about we just call it theta, is 224 degrees minus 180 degrees. Okay, what do you get? 44 degrees. You're like, that's not a usual reference angle. That's okay. Sometimes you get oddball reference angles. Good enough. Good? Okay. How about problem number 3? Let's take a look at that one. That is 17 pi over 12. Okay, so what should you all do? Good. You should write all these radians in denominators of 12. Because when I do that, it'll help me figure out which quadrant I'm in. So, well, 0, technically 0 pi over 12, that's easy. Pi over 2, denominator of 12, that would be 6 pi over 12, wouldn't it? Good. Pi over 1, good, that would be 12 pi over 12. 3 pi over 2, I'm making it into denominator of 12. So multiply by 6, right? 18 pi over 12. Oh! Doesn't 17 pi fall between 12 pi over 12 and 18 pi over 12? Then this is a quadrant 3 angle. Now let's find the reference angle. So if it's quadrant 3, we're going in the positive direction, aren't we? So the question to ask yourself is 12 pi over 12 plus what angle, theta, is equal to 17 pi over 12. Yeah, do your subtraction on both sides. You're going to get theta is equal to 17 pi over 12 minus 12 pi over 12 is, your reference angle is 5 pi over 12. Excellent. By the way, FYI, your reference angles are always first quadrant angles. Just saying. Okay, I have 3 more examples coming your way. If you haven't tried them yet, try them before you continue this video. See you soon. Okay, hopefully you've worked on these. Here we go. Number 4. Ooh, that's negative pi over 6, isn't it? So if it's a negative angle, is it going in the direction of the labeling or is it going in the direction against the labeling? Yeah, it's going against it, or clockwise, depending upon which way you'd like to look at it, all right? So here is a suggestion. Since the angle is negative, and I'm looking ahead and number 5 is too, and they're both in radians, numbers 4 and 5, I am going to write my radian angle measurements in the negative angle mode. For instance, this would still be 0 radians, but when I go in the clockwise or the against the labeling, this is actually a negative pi over 2, isn't it? Remember, 90 degrees is equivalent to pi over 2, which means each quadrant is pi over 2 radians. Just like in degrees, each quadrant is 90 degrees. But when I go against the labeling, it's going to have a negative value. And this would be, good, negative pi. This would be negative 3 pi over 2. And then I end at negative 2 pi. Good? Okay. So let's take a look. Number 4 has denominator of 6. These have denominators of 2's and 1's. So let's make them into denominators of 6. So technically 0 pi over 6, right? This one, negative 3 pi over 6. Oh, wait. 0, negative 3. Huh. I think we found our quadrant, didn't you? Don't you? That's a negative 1. So what quadrant is it? Yeah, this is a quadrant 4 angle. Okay, doing great. And now, that means from the x-axis, you're going in this direction. Remember, what's the word I'm looking for? Reference angles are always off of the x-axis. Good? Okay. And when you go against the labeling or in the clockwise, that's a subtraction problem, isn't it? All right, well, this makes it easy. So if you really want to set it up, you're doing 0 minus theta, because you have no idea what this is equal to a negative pi over 6. And if I do some algebra, I can say negative theta equals negative pi over 6 minus 0, which makes no sense, but whoops, that's a 0. Which means theta is equal to a positive pi over 6. Your reference angle is a positive pi over 6. Remember what I mentioned. Reference angles are always which quadrant? Quadrant 1. So even though the angle was negative, the reference angle is still positive. Good? Okay. Now, number 5. So negative 5, or problem number 5 is a negative angle, which means we're still going against the labeling or in the clockwise position, whichever description is better for you. But I'm having a challenge again because I'm noticing all my angles in radians have a denominator of 2 or 1. And I need them to have denominators of 24. So here we go. this would be equivalent to 0 pi over 24, right? 0 would be 0 pi over 24, right? Okay, this one, denominator of 24. Yeah, multiply by 12. So negative 12 pi over 24, right? This is over 24, okay, which means, oh, pardon me, this is over 1, but you want it over 24, which means negative 24 pi over 24. Wait. This is negative 12 pi over 24. This is negative 24 pi over 24. Negative 19 falls in between there, right? Okay, so what's your quadrant? Your quadrant is quadrant 3. Good. And now I need my reference angle. Okay. Remember, the reference angle is always off of the x-axis. So I'm going into quadrant 3. And when you go in this direction, that is with the labeling, it's the positive. And you're supposed to end up at negative 19 pi over 24. Okay, so how are you going to set this up? Good. You're going to take the reference angle, which is what? Negative 24 pi over 24. You're supposed to add some theta to it, and that's supposed to equal a negative 19 pi over 24. Okay, so add 24 pi to both sides, right? I know some of you may have a different way of figuring this out. Some of you are like, do I have to set up this equation that you're doing? No, you don't have to. But I'm just making certain you know how to find it, right? So what's negative 19 plus 24? That would be 5 pi over 24. And yes, that is definitely a quadrant 1 angle, isn't it? Okay, you guys are doing great. Number 6, last one. Did you get it? Okay, we'll work it out while I'm erasing because I need some board space. And I like my work to be a little bit cleaner than what it is right now to make sure that you can follow along with me when I finally get my answer. Okay, so, it looks like I don't need these negative angles anymore either, do I? Because that's a positive angle in radians, isn't it? All right, so let's do this. Bye-bye, bye-bye, bye-bye. Everything is labeled. Okay, I'm going to catch up to you now. I'm going to label everything. We have 0, we have pi over 2, we have pi, we have 3 pi over 2, we have 2 pi. Change everything into denominator of 6. So 0 pi over 6, 3 pi over 6, that's over 1. So 6 pi over 6, over 6 times 3. 9 pi over 6, and 12 pi over 6, isn't it? That ends at 12 pi over 6. That's 23 pi over 6. It's more than a full circle, isn't it? Okay, so how did you come up with the quadrant? What did you figure out? Yeah, exactly. I'm agreeing. If I minus the full circle away from it, that'll give me how many radians are left over in circle number 2 or rotation number 2. So when I do this subtraction, what do you get? 11 pi over 6. That's the leftover. So 0 to 12 pi over 6, go another 11 pi over 6, and we end up in between. So that means it is a quadrant 4 angle. So 11 pi over 6 is the same location as 23 pi over 6. That's a quadrant 4 angle, isn't it? Does that make sense? Okay. And so I'm not going to deal with 23 pi over 6 because it's in the same location as 11 pi over 6. So from your x-axis, because you need the reference angle, you're going against the labeling, so you're subtracting. That is where the full circle would end, and you're going to subtract some angle, and that's supposed to equal 11 pi over 6. Do you have it? I know I do. Okay, so what? 11 pi over 6 minus 12? That means you have negative theta equals negative pi over 6, which means your reference angle is a positive pi over 6. Cool? Okay, let me look at number 6 again, because that may have been a little bit on the fast side for some of you. Denominator of 6, so I changed all my radians into a denominator of 6. I'm noticing the original angle was beyond 12 pi over 6, which means it went one full circle and then it entered a second rotation. And when I took away the full first rotation, I was left with 11 pi over 6, which ended up in quadrant 4 because it was between 9 and 12. And then I did what I usually do. I took the x-axis angle, I subtracted this angle, and it had to equal 11 pi over 6. Cool? Okay. Hopefully this makes sense to you, and I hope you have fun with it. Catch you on the flip side.